everyone, welcome to section 12.3. So in this section we're going to look at another kind of special sequence called the geometric sequence. You saw last section arithmetic sequence is like a linear function because you're increasing by a constant amount to go to the next term in the sequence. The geometric sequence is like a exponential function because you're multiplying by the same ratio, by the same factor to get to the next term in the sequence. Okay, so what you're looking for to figure out whether it's a geometric sequence or not, the ratio between consecutive terms is always the same. So if you're dividing a term by the previous one, it should give you the same number, and that number is called a common ratio. All right? So let's look at this next example and figure out if these sequences are geometric or not. Okay? So part A, we have 4, 8, 16, 32, 64, 128. Okay? So you're basically looking, if I divide a term in the sequence by the previous one, I should get the same thing each time. So 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. It's 2 and 2. So you can see that they all divide. You take a value in the sequence and divide by the previous one. So it's important you're working backwards. So to find the common ratio, it's backwards. 32 divided by 16. 64 divided by 32. Alright, so if you look forwards, you can say that if I'm multiplying by the common ratio, I get the next one. So 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay? So this is geometric. And the common ratio is that number, it's 2. Alright? So this is like, with the exponential function, we call that the base. So the base of the exponential. This here we're calling it the common ratio. All right, let's look at the next one. -2, 6, -12, 36, -72, 216, ... Okay, so divide a number by the previous one. 6 divided by -2 is -3. -12 divided by 6 is -2. So this doesn't work because the pattern is broken. I'm not getting the same common ratio, so this is not geometry. Alright, let's look at the next one. 27, 9, 3, 1, 1/3, 1/9. Alright, so 9 divided by 27, 9 divided by 27 is 1/3. 3 divided by 9 is 1/3. 1 divided by 3 is 1/3. 1/3 divided by 1 is 1/3. 1/9 divided by 1/3 is 1/9 times 3/1, which is 1/3. So it's consistent. So this is geometric. And the common ratio is 1/3. All right. Notice that when the common ratio is bigger than 1, it's increasing. When the common ratio is between 0 and 1, it's decreasing. Okay, just like with exponential functions, right?